The GDP benchmark, a new frontier for measuring AI capabilities in professional knowledge work abstract. This article examines OpenAI's recently released GDPval benchmark, which represents a significant advancement in evaluating artificial intelligence capabilities on economically valuable knowledge work. Unlike previous AI evaluations that focus on academic reasoning or specific domains, GDPval assesses performance on real-world tasks spanning 44 occupations across 9 major economic sectors that contribute $3 trillion annually to the U.S. economy. Analysis of benchmark results reveals that frontier AI models are approaching expert-level performance on many professional tasks, with the best models winning or tying with human experts approximately 50% of the time. The benchmark also demonstrates that human-AI collaboration strategies can potentially increase productivity while maintaining quality. This article synthesizes the methodology, findings, and implications of GDPval, offering evidence-based recommendations for organizations seeking to integrate AI capabilities into knowledge work processes. While these results show impressive AI progress on standalone professional tasks, they should be interpreted as indicators of task-level capabilities rather than predictions of occupational displacement. The question of how artificial intelligence capabilities translate into economic impact has become increasingly urgent as frontier models demonstrate remarkable abilities across domains. However, measuring this translation is challenging. Traditional economic indicators like GDP growth attribution, adoption rates, and sectoral productivity changes are lagging indicators that only become visible years after technological diffusion begins. Brynjolfsson and Hitt. 2000. OpenAI's GDPval benchmark offers a new approach, directly measuring AI model performance on economically valuable knowledge work tasks that span major sectors of the U.S. economy. This evaluation represents a methodological breakthrough in understanding AI's potential economic impact before widespread adoption occurs, providing organizations with unprecedented visibility into where and how AI might augment or transform professional knowledge work. This article analyzes the GDPval benchmark's methodology, findings, and implications, offering evidence-based guidance for organizations navigating the integration of AI into knowledge work processes. We examine not only raw performance metrics but also the patterns of success and failure, cost-benefit considerations, and strategies for effective human-AI collaboration that maximize the strengths of both. The AI Capability Assessment Landscape defining economic value in AI capability measurement. Traditional AI benchmarks have typically focused on abstract reasoning, Liu et al. 2023, specialized professional domains, Miserendino et al. 2023, or academic knowledge, Hendricks et al. 2020. While valuable for measuring progress in specific areas, these approaches often lack direct connection to real economic value, the actual work people perform in the economy. The GDPval benchmark innovates by defining economic value through representativeness across major economic sectors, occupational task coverage, and professional quality standards. Each task in the benchmark is tied to the U.S. Bureau of Labor Statistics occupational framework and associated with labor market valuation based on compensation data, U.S. Bureau of Labor Statistics, 2023. This grounding in economic reality provides a more meaningful assessment of AI's potential impact than abstract reasoning tests. Prevalence, drivers, and distribution of AI capability measurement. AI capability measurement has evolved through several generations. Early benchmarks focused on narrow capabilities like image classification or question answering, Wang et al. 2019. The emergence of large language models led to benchmarks measuring reasoning, knowledge, and instruction following, Hendricks et al. 2020. Brown et al. 2020. Today's frontier of AI evaluation is characterized by multimodal assessment, evaluating models' abilities to process and generate across text, images, audio, video, and structured data. OpenAI, 2023, Complexity Scaling, Measuring Performance as Task Complexity Increases, Shrivastava et al. 2022, Professional Domain Depth, Assessing Specialized Professional Knowledge and Application, Katz et al. 2023, Human Comparative Evaluation, Directly Comparing AI Outputs to Human Professional Work, Potwadden et al. 2024, GDPval represents the latest evolution, combining these approaches while adding economic representativeness and task realism. The benchmark covers tasks across 9 major GDP contributing sectors: real estate, 13.8% of GDP, manufacturing, 10.0%, professional services, 8.1%, government, 11.3%, healthcare, 7.6%, finance, 7.4%, retail, 6.3%, wholesale trade, 5.8%, and information, 5.4%. Organizational and individual consequences of AI capability growth. Organizational performance impacts. The GDPval benchmark offers unprecedented insight into how AI capabilities might translate into organizational performance improvements. Analysis of the benchmark results suggests several key organizational impacts. Potential productivity gains, when comparing expert completion time, averaging 7 hours per task, to AI completion time, minutes. The benchmark demonstrates theoretical speed improvements of 90-327x for frontier models like GPT-5 and Claude Opus, Potwadden et al. 2024. However, when accounting for human review time and potential rework, more realistic productivity gains range from 1.12 to 1.39x for the best models, still substantial in economic terms. Cost efficiency improvements. Cost analysis from the benchmark suggests that using frontier AI models with human review can potentially reduce costs by 1.18 to 1.63x compared to fully human execution. For organizations with significant knowledge work components, this represents material financial impact. Quality variation across domains. The benchmark reveals significant variation in AI performance across sectors and task types. For example, Claude Opus 4.1 demonstrated particular strength in aesthetic tasks like document formatting and slide layout, while GPT-5 excelled in pure analytical accuracy, Potwadden et al. 2024. This suggests organizations may need to deploy different models for different work domains to maximize quality. Individual well-being and stakeholder impacts. The rapid advancement of AI capabilities has significant implications for knowledge workers, clients, and other stakeholders. Knowledge worker role evolution. As models approach human expert quality on discrete professional tasks, knowledge worker roles will likely shift toward oversight, quality assurance, and exception handling. Research by Brynjolfsson et al. 2023 suggests occupations will be partially rather than fully automated, with human-AI collaboration becoming the dominant paradigm. Skill premiums and evaluations. The benchmark results suggest certain professional skills may gain or lose value. Tasks requiring aesthetic judgment and multimodal communication, where AI still struggles, may command premium compensation, while routine analytical tasks may see downward wage pressure as AI becomes a viable substitute. Asimoglu and Restrepo. 2022. Client and consumer experience. As organizations implement AI for knowledge work, client expectations for speed, cost, and quality will likely adjust. The improved consistency demonstrated in the GDPval benchmark, particularly for well-specified tasks, suggests potential quality improvements for consumers of professional services. Frank et al. 2022. Evidence-based organizational responses. Strategic AI integration planning. Organizations can prepare for the capabilities demonstrated in the GDPval benchmark through strategic planning processes that identify optimal human-AI work configurations. Evidence shows that companies taking a strategic rather than opportunistic approach to AI integration achieve superior outcomes. Davenport and Ronanke. 2018. The GDPval methodology offers organizations a template for conducting their own capability assessments, task inventorying, systematically catalog knowledge work tasks across the organization, estimating time requirements and economic value. AI capability mapping for each task category. Assess current AI performance using benchmark data or internal testing. Integration priority matrix. Develop a prioritization framework based on potential value. AI readiness and organizational risk. Microsoft implemented this approach when integrating their Copilot AI assistant into Office applications. First mapping workplace tasks across roles, then prioritizing integration points based on capability confidence and business impact. This strategic approach helped them achieve 29% average productivity improvements while maintaining quality standards across professional functions. Domke. 2023. Augmentation model design. The GDPval analysis demonstrates that human-AI collaboration models outperform both pure AI and pure human approaches for many knowledge work tasks. Organizations can design augmentation workflows that optimize this collaboration. Effective augmentation models include try then fix, the human attempts to use AI first, reviews the output, and completes the task manually if the AI output is unsatisfactory. Draft and revise. AI generates initial drafts that humans refine and improve. Parallel processes. Both human and AI complete the task, with the human selecting the superior result or combining elements of both. McKinsey & Company adopted this approach for internal knowledge work, implementing a system where consultants and AI work in parallel on initial analyses, then collaboratively refine outputs. This implementation reportedly reduced analysis time by 40% while improving quality metrics by 15% through complementary strengths. Chue et al. 2023. AI capability enhancement strategies. The GDPval experiments revealed several techniques that significantly improved AI performance on professional tasks. Organizations can implement these approaches to enhance AI outputs, increasing reasoning effort. Performance improved with higher reasoning effort settings, with GPT-5 showing a 10% win rate improvement between low and high reasoning effort. Potwood et al. 2024. Contextual scaffolding, providing comprehensive context and detailed specifications increased performance by reducing ambiguity. Prompt engineering. Specialized prompting improved GPT-5 performance by 5 percentage points in head-to-head comparisons. Eliminating common formatting errors. Potwood et al. 2024. Goldman Sachs applied these techniques in their financial analysis workflows, implementing task-specific prompt libraries and multi-stage reasoning patterns that reduced error rates in financial models by 26% compared to standard prompting approaches. Stibe. 2023. Multimodal task process design. The GDPval benchmark revealed that models performed differently across file types and task modalities. Organizations can design workflows that account for these variations. Format-specific routing. Direct tasks to the most capable model based on file type requirements. Modality conversion. Convert tasks between modalities to leverage model strengths. Specialized tool integration. Supplement model capabilities with specialized tools for specific formats. Adobe implemented this approach within their Creative Cloud suite, routing different creative tasks to specialized AI models based on modality requirements. This architecture reportedly improved creative asset generation quality by 34% compared to using a single general-purpose model. Fleming. 2023. Quality assurance frameworks. The GDPval benchmark identified common AI failure modes in professional contexts, allowing organizations to design targeted quality assurance processes. Instruction following verification. Systematically check that all requirements in the task specification were fulfilled. Formatting validation. Implement automated checks for formatting errors. Particularly in visual deliverables. Factual accuracy review. Prioritize human review of factual claims and calculations. Reference adherence confirmation. Verify that all reference materials were properly incorporated. Deloitte implemented a similar framework for their AI-assisted audit procedures, creating a hierarchical review system with automated checks for formatting and completeness, combined with human review for judgment-sensitive elements. This approach reportedly reduced quality incidents by 47% while maintaining productivity gains. Raphael. 2023. Building long-term AI human work capability. Knowledge work process redesign. As AI capabilities continue to evolve along the trajectory demonstrated in GDPval, organizations need systematic approaches to redesigning knowledge work processes. Evidence suggests successful transformations follow these principles: decomposition and recomposition. Break existing processes into constituent tasks. Evaluate AI capability for each, then reassemble into optimized workflows. Boundary identification. Clearly delineate tasks requiring human judgment versus those suitable for AI. Interface design. Create interaction patterns that facilitate smooth handoffs between human and AI contributors. JPMorgan Chase applied this approach to transform their document review processes in legal and compliance functions, decomposing workflows into discrete steps and creating human-AI handoff protocols. The redesigned processes reportedly reduced document processing time by 58% while improving accuracy by 12%. Diamond. 2023. Skills ecosystem development. The GDPval results suggest knowledge workers will need evolving skill sets to effectively collaborate with increasingly capable AI systems. Organizations can prepare by developing comprehensive skills development strategies. AI interaction skills. Train knowledge workers in effective prompting, output evaluation, and refinement techniques. High judgment capabilities. Develop capabilities in areas where humans maintain advantages, such as ethical reasoning, creative ideation, and stakeholder communication. Technical literacy. Build understanding of AI capabilities and limitations without requiring deep technical expertise. IBM implemented this approach through their AI Skills Academy, which provides role-specific training paths for professionals across functions. Program graduates demonstrated 43% higher productivity when working with AI tools compared to non-trained peers. Krishna. 2023. Governance and ethical frameworks. As organizations adopt AI for knowledge work following the capabilities demonstrated in GDPval, they must implement appropriate governance structures, output accountability systems, establish clear responsibility chains for AI-generated work products, quality monitoring processes, implement ongoing sampling and review of AI outputs for accuracy and appropriateness, ethical usage guidelines. Develop principles for appropriate AI deployment across different knowledge work contexts. EY developed a comprehensive AI governance framework for their advisory services that includes task-level appropriateness assessment, quality control sampling protocols, and clear accountability structures. This governance model reportedly reduced adverse incidents by 67% while supporting scaled AI adoption. Weinberger. 2023. Conclusion. The GDPval benchmark represents a methodological breakthrough in assessing AI capabilities for professional knowledge work, offering unprecedented insight into model performance across economically significant tasks. The findings demonstrate that frontier AI models are approaching expert-level performance on many professional tasks, with the best models winning or tying with human experts approximately 50% of the time. However, the results should be interpreted as capabilities on discrete tasks rather than predictions of occupational displacement. The benchmark data suggests that human-AI collaboration strategies offer the most promising approach, potentially increasing productivity by 12 to 39% while maintaining quality standards. Organizations can respond to these findings by implementing strategic AI integration planning, Designing effective augmentation models, applying capability enhancement strategies. Developing multimodal task processes, and implementing robust quality assurance frameworks. Longer-term preparation should include knowledge work process redesign, skills ecosystem development, and comprehensive governance structures. As AI capabilities continue to evolve along the trajectory demonstrated in GDPval, organizations that take a systematic, evidence-based approach to integration will be best positioned to capture economic value while managing associated risks and transitions.